based on special right triangles. Okay, so let's look at this unit circle completely filled out and just talk about some of these features. So again, I did my colors differently so we could kind of focus on just our x values here first. So remember, x is our horizontal distance here. So when we're talking horizontal distance, we're talking about a measurement of cosine, right? So we're going this way. This is going to be our adjacent. So if we think about our angle being right here, then our adjacent side is going to be our horizontal distance, also known as our cosine. So all of these are going to be cosine values. So if you go ahead and plug into your calculator the cosine of 60 degrees, you're going to get 1/2. If you plug in cosine or sine of 60 degrees, you're going to get square root 3/2 because our vertical distances here, are going to be sine measurements, right? So when we talk about our angle here, our 30 degrees, and we talk about sine, we talk about opposite over hypotenuse, right? Our opposite over our hypotenuse. So opposite is going to be a vertical measurement. So all of our y values are actually representing sine. So the sine of 30 degrees is 1/2. If we go over here, the sine of 150 degrees is going to be 1/2 as well. But down here, notice, now we're in the negative. All our values are negative. So the sine of 210 is going to be -1/2. Okay, so let's look at that. Positive, right? This is the first quadrant. So we know that all of our x, y values here are positive. So we have our positive x, positive y. As we go to the left, now we have negative x. We're still positive y though. Again, be thinking about these things in terms of cosine and sine as well. So we're talking about a cosine measurement here. Our vertical measurement is our horizontal measurement is a cosine measurement. And our vertical measurement is a sine measurement. So over here, cosine is going to be negative, but sine will remain positive. Okay, as we go around this unit circle, now we're going to be negative, right? And then over here, we are still in the positive x direction, but we're going in the negative y direction. So if you look at my ordered pairs as we move around this unit circle, all these ordered pairs are going to mirror what you think. Remember, what we're doing here is just looking at this circle as if this point right here were 0, 0 on the coordinate plane. Okay, so let's talk about degrees. We said that we're going to go, the big gaps are 30 degrees and the smaller ones are 15. So we go 30 plus 15 is 45. 45 plus 15 is 60. Now we have another 30 gap. 60 plus 30 gives us our 90. 90 plus 30 gives me 120, plus 15, 135, plus 15, 150, so on and so forth around this unit circle. Remember to convert from from degrees to radians. We're going to take our degrees and multiply by pi over 180. So right here, we have, if we have traveled all the way around this entire unit circle, then we've gone 360 degrees, and that is equivalent to 2 pi. You can do the same exact thing to get all of these conversions. So to go from 30 to pi over 6, I would take 30, I would multiply by pi over 180, and when I simplify that down, I'm going to end up with pi over 6. And that's how we get all of these conversions here between our radians and degrees. We talked about where all these ordered pairs come from. Again, that's built on our special right triangles. And then you really just have to pay attention to your signs, positive or negative. Okay, another thing I want to point out. Notice that square root 3/2 and 1/2 are always buddies. So even up here, they switch spots, but they're still together. And square root 2/2 and square root 2/2 are always together as well. All right, so let's think about what all of this means. If we have a 30-degree angle, boop, so we're going to draw that something like that, right? There's my 30-degree angle. This is 30 degrees right here. And we want to figure out what these measurements are. Well, I know that sine is opposite over hypotenuse, and my opposite, that's my short leg, that's a measurement of 1/2, and my hypotenuse is always 1. So 1/2 divided by 1 is just 1/2. Okay, cosine is going to be my adjacent side. My adjacent side here is the long leg of my 30, 60, 90, so that's square root 3 over 2 divided by my hypotenuse, which is 1. So this is just square root 3 over 2. Slightly more complicated. Now we have tangent. Well, tangent is opposite over adjacent. So now I'm going to take my 1/2, my short leg measurement, 1/2, and divide by square root 3 over 2. So I'm going to take 1/2 and divide by the square root 3 over 2. Okay, now you have a fraction divided by a fraction. That's a little intimidating to look at. I prefer to write it like this. Then we remember the rules for dividing with fractions. We invert and multiply. So we end up with 1/2 times, let's not do that. Let's do 1/2 times square root 3 over 2. We're going to multiply across the top, square root 3, multiply across, oops, hello, get it together for now. That was not giving me the answer I expected to see, which is how I caught my mistake. When we invert and multiply, you must invert. 2 over square root 3. There we go, that looked better. Now my 2's cancel out, and I end up with 1 over the square root of 3. But at that point, your brain should be saying, oh no, not allowed to have a radical in the denominator. So we multiply by 1, square root 3 over square root 3, and we cancel out our radical in the denominator. We end up with square root 3 over just plain old 3. So tangent is going to be square root 3 over 3. Okay, you can do that for the 45 and the 60, but let's look at the 210 together because we haven't specifically talked about that. Okay, 210 is going to be like this, right here, approximately 210 degrees. This is also a 30, 60, 90. This reference angle here is 30 degrees. So to get from my x-axis down to this 210, it's a 30-degree move. So this is going to be based on a 30, 60, 90 triangle. And now I just need to pay attention to negatives and positives. So again, sine, we're going to be talking about this distance here, this vertical distance, and it's negative because we're going down. So this is going to be negative 1/2 over 1, or just negative 1/2. Cosine is also in the negative direction. My adjacent measurement here is also negative, square root 3 over 2 divided by 1, again, just negative root 3 over 2. Tangent. Okay, well now I have a negative divided by a negative, right? We have a negative direction here and a negative direction here. My opposite and my adjacent are both going to be negatives, so I'm going to end up with a positive, and it's just going to be the same as it was here. So this is just going to be positive square root 3 over 3. All right. Let's look at this and what this thing means. So what are these ratios? Are they positive or negative? Let's draw a right triangle and check it out. So if we draw a right triangle in quadrant 2, right, we're just going to draw a right triangle in there. Again, if we're thinking about this in the unit circle, the hypotenuse would be 1. But let's just talk about our sine and our cosine. Okay, in quadrant 2, I'm going in the negative x direction. And remember that x is a, the horizontal measurement here is a measure of cosine. So cosine is going to have a negative value here. Sine, however, is a vertical measurement. We're going up here. So the sine is going to be positive, and the hypotenuse is positive. So positive, positive, giving me a positive relationship here. However, cosine is going to be a negative divided by a positive, and that's going to give me a negative. So cosine is going to be negative in the second quadrant. And tangent is going to be a negative divided by a positive, so it's also going to be negative. Again, tangent is opposite, a positive value, over adjacent, in this case a negative value. A positive divided by a negative is a negative. All right, you guys try and fill out the last bits of this and let us know if you have questions. Hope you're doing well. Miss you all.